Okay, we're going to continue chapter 15, and now we're actually going to get into the math portion where we start actually ricing equations. Rice, and we did a little bit in pre-AP. The R stands for the reaction. The I stands for the initial amounts. And initial amounts can either be in molarity, and it's real important that if it's in moles that you change it to molarity. It can be in molarity, or it can be in atmospheres if we're talking about Kp for gases. C stands for change in. It's going to be how much the initial amount changed by. You're going to use the coefficients and do ratios for this particular part. And then the E is going to stand for equilibrium. And at equilibrium is where we calculate our equilibrium constant, is where we do K. So RICE, we're going to be doing what we call a Rice table: reaction, initial amount, change amount, and equilibrium amount. So we have a worksheet here that we went through. There's basically 6 types of problems. We're going to go through each type. The first one is known as, this is if you were given, it says all beginning amounts are given, and we're given one equilibrium amount. It says if we have 2 molar nitrogen is placed in a container with 4 molar of hydrogen and 5 molar of ammonia, and then that was the initial amount. So I'm going to come over here and try to write small on this Word document. We're going to have RICE, and we'll draw a line, and we've got N2 plus 3H2. This is not going to work very well. Probably going to have to go to a separate sheet of paper. So I'm going to go to a blank page. Hopefully I can remember those amounts. I may have to pause and get up a copy of the worksheet. So you've got nitrogen plus 3 hydrogens, and that is making ammonia. And if we go back and look, it says that we've got 2 moles of nitrogen is placed in a container with 4 moles of hydrogen and 5 moles of ammonia. So 2, 4, and 5. So 2 moles, 4 moles, and 5 moles were placed in molar, not moles, were placed in a container. And it says after some equilibrium has been established, we end up with a 2 molar of hydrogen. So they gave us all the beginning amounts and one of the ending amounts. And because they gave us one of these ending amounts, we can actually figure out one of the ends. You've got 4 here, and now it's 2, so you can see that it lost 2 molar. And that's a hint, 4 here and 2 here. So we got to figure out what the others lost. This one must have lost as well. If you lose on the reactant side, you gain on the product side. Vice versa. If I would have lost here, I would have gained here. So these are both going to be negative. This will be positive. If this had been negative, these both would be positive. So they're going to be opposite because remember the reactions going back and forth at equal rate. So this is, now we use coefficient. For every 3 of those, there's only 1 of those. So the N is 1/3 of whatever the H2 is. And since this is 2, this would be 1/3 of it, which would be 2/3, or 2 divided by 3. And if you can't see that, you can set up a ratio. For every 3 hydrogens, there is 1 nitrogen. So therefore, if this guy is 2 molar, you could figure out this guy by doing some little cross multiplication there. And that is going to be 0.67. So if we take 2 and subtract 0.67, we will get 1.33 molar. Now we could do the same and go this direction. This is a 3:2 ratio. So you could change your ratio here on the bottom. And now we could say, well, for 2NH3, so it's going to be 4 divided by 3. Or if you like, this is a 1:2 ratio. 1:2 ratios are easier to see. For every 1 of him, there's going to be twice as much of him. So this is actually going to be 1.34. And again, it's positive because if you subtract on the reactant side, you add on the product side. So this is going to become 6.34. So now that you have your E values, you can simply plug them in. And remember, this is Kc because it's molarity. Products over reactants raised to their coefficient power. So this would be 6.34 m raised to the second power over 1.33 m raised to the first power times 2 m raised to the third power. And then we would just plug that in our calculator and solve. If we go back to the sheet there, we can see that that answer should be giving us 3.8. So that is, again, all beginning amounts given. One equilibrium amount is also given. Second type of problem, we got a more generic equation. This one's going to give me a little bit more room I can write with. Good. So we've got A plus B making C plus D. We're just going to assume they're all gases or maybe all aqueous just because we want them to all be part of the reaction. So our R is the reaction. And C plus D. And we've got the I. It says, well, they've given us a K. K equals 49. The hint I gave them in class, anytime they give you a K value in your rice table, you will have X's. If they give you a K, you will use X in your rice table. If you don't know K, then they must have given you some other clue, and you won't be using X's. It says, if 0.4 moles of A and B are placed in a 2-liter flask, what are the concentrations of these at equilibrium? So first off, we would need to change our moles to molarity. So 0.4 moles divided by 2 liters is going to be a 0.2 molar solution. This would also be a 0.2 molar solution. This guy would be 0, this guy would be 0. And the reason we know these are zeros, it didn't say anything about them. We just put the A and a B in a flask. They're going to react together and make C and D. Now, because these two things are zeros, we know exactly where we're putting positives, because you can't subtract from nothing. You can't put your negatives here if you don't have anything. So we're going to be subtracting here. We don't know how much, but since we know the K, we're going to be using X's. This is going to be minus X here. This is a 1-to-1 ratio, so this will also be X. If this problem had a 2 here, this would have been 2X. Okay, if it had a 5 here, it would be 5X. So you are going to pay attention at the C to the coefficients. So I'm going to go ahead and take both of those off or we won't match this answer. And then we've got X and we got X because this is a 1-to-1 ratio, 1-to-1. These are all nice. So you're going to end up with 0.2 minus X, 0.2 minus X. We got X and we've got X. We keep scrolling down. Let me pull that back just a little. We can still see. Okay, this is going to end up being your C times your D. So you're going to have X times X to the first power. So that's going to make X squared on top. And then we're going to end up with 0.2 minus X times 0.2 minus X on bottom. And that's going to equal 49. Now I showed them we can use the solver for this. In the next few problems we're going to have to use the solver. Remember to use the solver. You zero stow X to begin with. You type in your equation so that everything is on one side, so the 49 would have to move over to the other side. And then you hit alpha, enter to get it to solve. So if you need help with the solver, you need to come in. This particular problem could be worked without the solver. And the reason it can be worked without the solver is because you've got a square on top and a square on bottom. You could actually take the square root of both sides, and this would be 7. And this would be X over 0.2 minus X. And now you could actually cross multiply and solve. Get X on this side, 1.4 minus 7X. And then you could combine your like terms by adding a 7X over here, which is going to make 8X, 1.4. You would divide by 8, and you're going to find out that X is 1.175. If I trace back up at equilibrium what X is, you'll find that X is 0.175 here and 0.175 here. In order to find this guy and this guy, I take 0.2 minus X, so you get 0.025. and 0.025. And that's as simple as that one gets. Okay, our next one is going to work the same way. The only difference is it says you have to use the quadratic. I'm not going to work through this one because it is a Friday afternoon and almost 5. It works the same way, but it says you would have to use the quadratic. You do not need to use the quadratic because you can use the solver in your calculator. These are the answers you should get when you use the solver. So this one works just like B. So I'm going to move on to this next one. And honestly, this one's going to work the same way. I just showed them a trick with this one. I'm going to come here and we go RICE. You will have HF, which is hydrofluoric acid, making some hydrogen ions and some fluorine ions. It says you have 0.2 of this, so that is our beginning. It doesn't say it's at equilibrium. It doesn't mention anything else, so these guys would be 0. It's giving us a K, so that's going to tell us we're going to use X in our equation. Since these are zeros, we're going to be adding on this side, and we're going to be subtracting on this side. And these are all 1 to 1, so very, very nice. This will be X, this will be X, this will be X. Be 0.2 minus X, X, X. So then products of a reactant, so this is going to be X squared because it's going to be X times X on top, and then 0.2 minus X on bottom. You set that equal to the K. Now, this one could use the solver as well, but if you were kind of a little bit afraid of the solver, I showed them a trick with, as long as this number here is to the -4th or smaller, -5th, -6th, etc., the power, you can actually mark through this little minus X here, and that's what we allowed you to do in pre-AP. Then you can throw this guy over 1 and do some cross multiplication. You end up with X squared equals 1.44 times 10 to the -4th. And then you could take the square root of them. You'll get X equals 0.012. And this particular question just asks for the HF concentration. So there's the the H plus concentration. So there's the concentration. If it had asked the fluoride, it would also be the same thing. If it had asked for HF after equilibrium, you would take 0.2 minus 0.012. So you would get 0.188 molar here for that one. But the question didn't ask, that's why you don't see that answer there. Alright, our last type, 29 in the homework, is going to be similar to this problem, partly. It has something to do with the reaction quotient. The reaction quotient is not K, which is the equilibrium constant. The reaction quotient is the letter Q for quotient. What the Q does is allows us to know whether or not we're at equilibrium or where we're past it or haven't got there yet. If our Q is less than K, that means we haven't got to equilibrium yet, and the reaction is going to go forward. If the Q is greater than K, then that means we kind of overshot equilibrium, and we got to go backwards and go back the other direction. If they're equal, then we are at equilibrium. So here's our example. Let me scoot this up. We've got Ri. We're going to do this part first. H2 plus I2. Number 29 is going to have you calculate the Q for different reactions. Alright, and this is 2HI. It tells us the initial amount of this guy is 0.08. The initial guy of this is 0.06. And the initial of this is 0.79. Okay, now, nobody's 0. Since nobody's 0, and then they didn't give us any hints down here, I cannot actually know where my pluses and minuses are going to be. I don't know if it's going to be making more product or making more reactant. So what you have to do is you have to find out if we're close to equilibrium, if we went past it, or if we need to keep going. So we use the I to calculate Q. We use E to calculate K and I to calculate Q. In order to find Q, it works the same way. You take the products, which is going to be 0.79 molar. You raise it to that power, divided by the reactant, so it's going to be 0.08 molar. And this is going to be 0.06 molar. And these are both to the first power. And I'm not sitting near a calculator, but if I can remember correctly, and I may be remembering wrong, I think this was 130. You can check my math there. It was 100 and something, but I'm not 100% sure. Okay, so at equilibrium, if you'll read our problem here, K is 50. Well, the Q, where we're at right now, is 130. So Q is greater than the K, so therefore the reaction is not going to keep going forward. It's actually going to go backwards. What that means is, instead of adding on what we normally would put the reactant side, we're actually going to add on the product side. Instead of adding on the product side, we're going to add on the reactant side. That's what this tells us, because Q is more. It tells us where to put the pluses and minuses. Now I can start using x's. This guy would be x. X, there's a 1 to 1. This one's a 2, so this is actually 2x. So again, the reason I did this Q is to figure out the plus and minuses. And now we're going to have E. On number 29 on your homework, that's all they want you to do, is to figure out Q and find out if it's going to go forward or backwards. It's not going to make you rise it. This one we're going to go ahead and rise. We know that we're using x's because I've been given a k. So now I would take 0.79 minus 2x and square that. And I'm going to divide by 0.08 plus x times 0.06 plus x. And we're going to set that equal to our Q, which is 50. And then you're going to solve using the solver. Once you find x, you're going to take that value and plug them in to these to find your answers. And these are supposed to be the answers, but I think they're a little bit rounded off. Every year I think I'm going to go back and change these and I forget. But if you store your x in your calculator, I think this is 0.724. They're off by less than 100. I think this might be 0.114. But they're really, really close, so you can go back and check. So that is the 7 types of problems that we did. And then we had an assignment, and I may need to pause this for just a second to find where your assignment is. So I'm going to pause. Okay, I went and got the assignment, but I also went and found exactly what the x was in that previous problem. If I can find where I wrote that previous problem. Down here. That way I could actually, well, apparently it's not going to let me go down there, maybe. There we go. I actually found the x when I got up. 0.0329 is what x should come out to be. And then if we plug back in 0.8 plus x, you are actually going to get for H2, it comes out to be 0.113 molar. Oops, actually this, molar. Making sure we weren't back in atmospheres. And then I2 would be 0.06 plus our x. You get 0.0929 if we did 3 sig digs. And then for your HI, you would get 0.79 minus 2x. You get 0.724 molar. So those are the answers. I think I'm going to make sure I correct them before I upload them to Edmodo. So those are the correct answers.